Hello, class. This is Mr. Hart, and in this podcast, I want to finish up the Earth, Sun, and Moon system chapter of our textbook. And this week, we really talked a lot about the sun. Now, the sun is definitely the most important part of the solar system. If we didn't have it, we wouldn't have the solar system, right? And it really is the most massive part of our solar system by far. It makes up 99% of the mass of the solar system, which means if you took any particle in the solar system, there's a 99% chance that it was in the sun at the time you picked it, which is pretty crazy if you think about it. So it is huge. And it, again, has a lot of unique features to it because it's powering our solar system. It has this inner fusion that's occurring, and so it creates these different layers in the sun. Okay, and we're going to look specifically at these different layers. So if you think about a jawbreaker, right? If you've ever eaten a jawbreaker, you can't really bite into it, but if you imagine you cut it in half, there would be different layers on this jawbreaker. Okay, and the sun is just the same way. Okay, there's different spots, different layers to the sun. Okay, there's the inner core, the radiative zone, the convection zone, the photosphere, the chromosphere, and the corona. Okay, and so I'm going to move on from this picture because it's a nice picture, but we really want to look at the mechanics or what's making the sun work the way it does. Okay, so to start out, let's just write down these 6 layers: the inner core, the radiative zone, the convection zone, the photosphere, the chromosphere, and the corona. Okay. And then as we go through, I want you to write down the definition that makes sense to you, because I could write the official definitions up here, but it wouldn't really give you a good idea of how the sun is working. Okay? All right, so I'm going to kind of draw a very, very simple depiction of the sun's layers and what they do. Okay, so again, this might be a little bit of an oversimplification, but I think it gives us a good idea of what's happening. Okay. So first of all, we got to start off with the core. Okay, the inner core. And the core's job is to basically be the power source, right? This is where the nuclear fusion is occurring in the sun. Okay, so this is where particles are smashing together, right? And they have so much energy and heat that they actually fuse together. Okay, so hydrogen slams into each other and it becomes helium. Okay, this is the main power source of the sun. Okay, so any type of fusion has to be happening in the core. Okay, then the next layer is the radiative zone. Okay, and its job, if you want to think about it, is it takes all that energy from these fused particles and it releases it as heat and light. Okay, now that's not the only thing it does, but for this class, that's a good enough description. So it's taking all that energy and it's releasing it out as heat and light, okay, from outside the core. Okay, so this is its job is to radiate that energy that was created from the nuclear fusion process. Okay, then um, there's the convection zone. Okay, and I apologize, I can't write very well or draw perfect circles with a touchpad, but you get the point. So then there's the convection zone, and its job is to take this core's old material, all this helium that's been used up, and kind of pull it out of the core and bring it out. Okay, because it no longer is needed because it's done its job, it's released its energy in the radiative zone, and so its job is to pull out the old material and then also to bring in new hydrogen into the core. If you've ever heard of convection, that's what it is, right? It's the circulation of material. It's kind of the same thing. It's to kind of move that old material out, okay, and bring new material in, okay. And again, this is a simplification, but for this class, this is how we're going to view it, okay. So there you go. There's the core, the radiative zone, and convection zone. And I like to call these guys the machine, okay, the machine of the sun. Okay, they're really responsible for making the sun have the energy it has, work the way it does, and keep it burning. Okay, if you didn't have these 3 zones, then the sun wouldn't work. Okay, so these are the internal, parts of the sun, the machine that is making the sun work the way it does. Okay, I'll put that in quotations. Okay, this isn't really what it's called, but I like to think of it as the machine. Okay, so those are the first three layers, right? Inner core, radiative zone, convection zone. Then there's the photosphere, the chromosphere, and the corona. Okay, so the photosphere and the chromosphere and the corona are all very small compared to the first three layers. Okay, they're very thin compared to the first three layers. Okay, but you can think of it like this: the photosphere is responsible for light, or is the visible part of the sun. Okay, this is the visible light coming from the sun. That's the photosphere. Okay, that's the photosphere. It's the visible light that is coming from the sun. Then there's the chromosphere, which again is pretty dang close to the photosphere. And this is kind of all the heat energy, okay, all the movement back and forth of the particles. Okay, that's what we know heat is, right? It's the movement of the particles. So the chromosphere is kind of responsible for the heat energy of the sun, or the material moving back and forth. And then last of all, the corona is kind of the crust, if you will. Okay, it's kind of weird to think of crust, but it's just a very thin layer of plasma that kind of goes around the entire edge of the sun. Okay, very thin. It's kind of the sun's crust, and it just encircles the whole thing. Just a thin layer of plasma. It's kind of the outer boundary of the sun. Okay. All right. So I know this picture is a little sloppy. Hopefully you can kind of understand and see everything that I wrote down. But just in summary, the core is responsible for the fusion. The radiative zone is responsible for radiating the energy out. The convection zone is responsible for bringing the new material in, taking the old material out. The photosphere is that visible light coming from the sun, or the visible layer of the sun. The chromosphere is kind of the heat layer of the sun, or the heat energy. And the corona is this kind of thin plasma that kind of makes the crust, or outer boundary of the sun. Okay? So there you go. Those are the different layers of the sun. And if we didn't have them, the sun wouldn't work the way it does. Okay? But try and memorize those and have a good understanding of what's happening and why it works the way it does. Okay? All right. So then we talked about a couple of features of the sun, particularly sunspots. Okay, so sunspots are very, very cold areas of the sun. Well, very cold relative to the other parts of the sun. Okay, so these black areas, or black spots on the sun, they're still pretty dang hot. If you just wouldn't want to be touching them still. Okay, but compared to everything else, they're very cold. Okay, and so sunspots are known for creating some strange magnetic fields. Okay, and when these magnetic field lines are going around the sun and they kind of move strangely and break, we get what are called solar flares. So when these magnetic field lines kind of move around in strange ways and break, they shoot out material from the sun itself. Okay, and these materials, just protons, electrons, kind of flying through the air. Okay, and again, it's kind of hard to understand why the breaking of the magnetic fields causes this, because we're not used to having so many magnetic field lines. But just understand that when this strange occurrence occurs, it will shoot out this material from the sun. Okay, here's kind of a side view of all this material getting shot out. Okay, this one blast is said to be as big as the Earth itself, so just ginormous amounts of material getting ejected from the sun. Okay. All right, but there you go. That's everything we talk about for the sun in this class. So if you are watching this presentation for participation, let's answer this question. Which layers are the machine of the sun? Okay. All right, then the next thing we talked about is we're just going to finish up with some of the other Earth, sun, and moon phenomenon, and one of those is eclipses. So A solar eclipse is when the moon blocks our view of the sun. Okay, so the moon is about 400 times smaller than the sun, but it's also 400 times closer to us than it is to the sun. So this strange ratio just kind of works out perfectly so that when it's in perfect alignment with the sun, it can block out the sun entirely for a small part of the earth. Okay? And so here's the sun, here's the light hitting the moon. It's blocking the earth, or blocking light from hitting the earth in this area. Okay, and there's two specific areas. There's the penumbra, which is this light shadow zone or partial shadow zone. And then there's the umbra, which is the total shadow zone. So if you're in the penumbra, you will see a partial eclipse. But if you're in the umbra, you will see a total eclipse. Okay. So here's some pictures of a solar eclipse. So if you've ever seen a solar eclipse, it's really cool. All you can see is just kind of the outer glow of the sun kind of hitting the moon. Really cool looking feature. Okay. Only happens every 300 years or so for the same part on Earth. Okay, it kind of moves around to different parts of the Earth. Happens about twice a year. Okay, but if you ever do get a chance to see a total solar eclipse, it's really cool. Okay, this is an aerial shot of a solar eclipse on the Earth, and you can just see this huge shadow zone from the eclipse. Okay, so you're just the Earth and just that huge shadow cast from the moon on the Earth. Okay. And here's a video if you want to go to it on YouTube showing a solar eclipse. It's pretty cool. Shows how it blocks out all the light. It's midday and it looks like it's nighttime because the light is just blocked. Okay. So solar eclipses are just awesome. Really cool. Then we have lunar eclipses, which is a little bit different. Instead of the moon blocking light getting to Earth, in a lunar eclipse, the Earth blocks the light getting to the moon. Okay. Earth blocks the light reaching the moon. And so as the Earth's in its orbit and the moon's in its orbit, if they line up perfectly, the Earth will cast a shadow on the moon, making the moon basically disappear, okay, causing a lunar eclipse. Okay, looks similar in the sky. You can see the shadow of the Earth going across the moon, same way you can see the moon going across the sun. Okay, but it's just a kind of a different perspective, but they're both eclipses. Okay. And so again, just to review the different vocabulary I need to know is eclipse is just an obscuring of light from one space body by the passage of another, okay, like the moon passing by, blocking out light from the sun to the earth, or the earth passing by, blocking out light from the sun to the moon. Okay, so other objects can do this, other planets, moons can do this. An eclipse is just an obscuring of light from one space body to another. Okay, then there's the penumbra, right, which is the partial shadow during an eclipse. And then there's the umbra, which is the total shadow during an eclipse. All right, and then the last thing we talked about was the tides. And so when the sun, the moon, and the earth all kind of line up together, we get some really high tides, which occurs because the moon's putting this gravitational pull on the earth's water. So it kind of bulges out. So if you're standing on the earth's surface right here, you'll see very high water in that area because the moon's pulling it up. Okay, that's kind of just a basic understanding of the tides. But we don't get a lot into it, but you should just understand that the tides are caused by the moon and by the sun. Their gravitational pulls pulling on the Earth's water and on the Earth cause the tides to either go high or low, and just based on where those three objects are at. Okay? All right, and if you are answering this for participation, answer this question. So a solar eclipse is when A, the sun blocks out the moon, B, the moon blocks out the sun, C, the earth blocks out the sun, or D, the moon blocks out the earth. Okay? All right, so that is it for this chapter and unit. So hopefully that made sense. Let me know if you have any questions, and thank you for watching.